Here we go. We have a question time taken to mark all nodes. We have a tree numbered from 0 to n minus 1 and edges. If I is odd, the node will mark at time x. If there is at least one adjacent node to it which are marked at time x minus 1. What it means is, if I am at ith node, then if I have to move to its neighbor, and if neighbor is odd, then I have to consider plus one time, and if the neighbor is even, we have to take plus two time. If the neighbor is odd, we have to take plus one time, and we have to return the time required to mark all the nodes starting at the ith node. So if we start from 0 to mark one node, we have to take time plus 1. So it will be one time to reach here. So if we have to move 2, so 2 is even, it will be plus 2. So the time taken to mark all the nodes starting from 0 is 2. If we start from 1, so the time is 0 here. To mark this node, it will be 2 time. To mark this node, it will be 4 time. So the answer is 4 for 1th node. If we are at this node, to reach this node, we have to take plus 2. So for 0, it will be 2. To reach this node, we have to take time plus 1. So the time is 3. So to reach all the nodes starting from ith node is 3. So let's build the approach. We have this. So we cannot start from every node and to reach every other node or to mark every other vertex. This will give us a TLE. So we have to optimize it. So we are at this node. To reach this node, first we have to calculate all the nodes, all the child nodes. So we will reach here and we will reach all its neighbor nodes, but we will not reach its parent again. So to reach all its child node, we have to take time 0. Then we have to go here. From 2 we have to go here. From 3 we have to go here. So to reach all its child node, the time taken is 0. To reach all its child node, we have to take time 0. From 3 we have to go this node. So to reach even node, we have to take time plus 1. So 0 plus 1. Then to reach this node, this is even, we have to take plus 2. So it will be 2. The maximum answer is 2. But we have to add the maximum value and the second maximum value. So we have to take two values. So we have to take two values here also. Here also. I will tell you the reason why we are taking the maximum value and the second maximum value. So from 2 we can go this node or this way. So this way we have 0 0. Then to reach 4 we have to take 2 time. Then to reach 3 we have to take 1 time. And from 3 to reach all the nodes, the maximum time required is 2. So from 2 to reach 3 we have to take plus 1, and from 3 the maximum time is 2. So the total answer is 3 here. The maximum answer is 3 here. To reach all the nodes starting from 2, the answer is 3. So starting from 0, either we can go this way, so the value will be 1. We can go, or we can go this way. So to go this way, this is even node, so we have to add plus 2. The maximum value is 3 here. So the answer is 5. This is about the 0th node, and as you can see, this is bottom up. We are first filling our bottommost node, then at the end we are filling our topmost node. So this is it for the 0th node. So the answer for 0, to mark all the nodes, the answer is 5. Then we cannot do the same operation for every node. So we have to make sure that we will optimize it. We are taking maximum and second maximum. With this, from 0 we have 1 and 5 at the maximum and second maximum, but we also have to track from where we are getting our maximum value. So the maximum value we are getting it is from 2. The maximum value is 5 and we are getting it from 2. So we have to do it for every node. So this is our distance array, and this is our you can say maximum distance. or maximum parent. So this three from here, the three we are getting it from 6, and next we have this three we are getting it from 3, then we have 5 we are getting it from 2. So we have filled our values. It's time to reach all the nodes. So now we have to fill this node. So for this node, we are going to its neighbor. So this is its neighbor. So we have to track all its child nodes. So the child node is 0, okay. But we also have to fill all the other nodes. So starting from 0, the maximum value is 5, and 5 we are getting it from 2. So we can use this. So to reach 0, we have to add plus 2, and to mark all the nodes, the time taken required for 0 is 5. So the time taken required for 1 is 7. It's time for 2. It's time for 2. So for 2, the child nodes required time is 3 or 2. 3 and 2. So the maximum we will take is 3, the maximum value. Then we have to reach 0. So 0 is even. So we have to add plus 2 plus the maximum value. But here the maximum value we are getting it from 2. From 2 itself we are getting our maximum value. So that's the reason we have to make sure that we add our second maximum value. The second maximum value is 1. The 1 means all the other nodes. So to reach 2 we have to add plus 2, and to reach all the other nodes, the second maximum value we have is 1. So from childs we have 3, and from parent we have 3. So the answer is 3. As you can see, the 3 is the maximum answer for 2. So we have filled for 2. It's time for this node, third node. So for 2, we have two ways. Either we can go on this way, either we can go on this way. So from parent we are getting 3. From parent we are getting answer as 3. So to reach 0, we have 2, and the second maximum value is 1. So to reach from tooth parent, we are getting our value 3, and from this side we are getting our value as 2. How we will find that? Because for this node, the neighbor node, tooth neighbor is 3, and the maximum value we are getting is 3 from 3 itself. So we will not include this value, we will take the second maximum value which we are getting from other childs. So that's how we will track it. So the maximum value is 2. So for 3, actually first we have to pass our value. So the maximum value is 3, so we will pass 3 here. So we will pass 3, and from 3 we have child nodes. So time required to reach all the child nodes is 2, and from its parent we are getting 3. But to reach 2 itself we have to take plus 2 also. So we will take 5 time. So the maximum answer is 5. So for 3 the answer is 5. I know it's bit complicated, but if you look at the code, it is very simple. Now it's time for 4. So for 4, first we have this value, and from parent we are getting as 3. So for parent we are getting it at as 3. So we will pass this value, and the maximum value we have 3. So 3 we are getting from other child. So we will pass 3 itself. So 3 here and 3 here. We have two paths, and to reach this node, 2 nodes, we have to also add plus 2, because from neighbors we have to reach this node. So we will add plus 2. So the maximum time is 5. So for 4, the child nodes we have 0 time maximum, and from parent we have 5 time maximum. So we will take maximum value. So for 4 we have 5 as answer. It's time for 6. 5. So for 5 we have this value, and we have parent node. So as you can see, we are getting 3 from here, 3 from parent, and to reach this node, tooth node, we have to add plus 2. So it will pass 5 as answer. Then we have this node. So this node we have, and to reach this node, this is a odd node, and we are getting 2 from this side and 5 from upper side. So we will take maximum value, which is 5, and to reach the third node, this is even, so we have to add plus 1. So from 5 we have child nodes as 0, and from parent 3 5, so it is 5 here. Then we have to reach third node, so it is 6. So the answer for 5 is 6. Answer for 5 is 6. Then we have to reach this node. So for 3, as you can see, we are getting 3 from here, and to reach this node we have to add plus 5 plus 2 here. So we are at this level. So from other, as you can see, 3 6, so we have maximum value as 2. So 2 we are getting it from 6, so we will take the second maximum value, which is 1. So this will pass 1, and from here we will pass 5, and we also have to reach this third node from where we are getting our maximum values. So we will, this is odd node, so we have to add plus 1. So the maximum value from these two is 5, and we will take 6 because to reach third also. So from 6 node, child node is 0 and parent node is 6. So the answer is 6 for 6. Answer is 6 for 6. That's all. Let's look at the code. So we have distance. So I am taking global array. Why I am taking this much size? Because it is given 10 raised to power 5. So 10 raised to power 5. So plus 1, because we also have to consider the last value. So I am taking the second parameter as 2, because we have to make sure that we consider second maximum value and maximum value. Then max child, it will store from where we are getting our maximum value. So this is our main function, time taken. First we have n, this is the edges, mn. So we will create our graph or tree. This is a undirected tree. Then we will find the distance from root. So this will give us the bottom up thing. Distance from root, we are passing adjacent 0 and parent. Parent we have to pass, so we will not visit parent again. So first we will take some variables, maximum, second maximum, and child. This is the child. If the neighbor is parent, just continue. Then we have to consider the maximum value from child itself. So this is bottom up thing. First we have to find from bottom nodes. So we are passing neighbor and node. If this neighbor node, to reach neighbor node, we have to, if the neighbor node is even, so we have to add plus 2. If it's odd, we have to add plus 1. So if this current distance is greater than our maximum distance, then we have to make sure that we consider this. The second maximum value, first we store our maximum value, then maximum value we will take this current value, and we have to also consider from where we are getting from. For the current node, we are getting it from this neighbor, the current neighbor, and if it is greater than second maximum, then update your second maximum. At the end, you have to add, you have to update your maximum and second maximum, and this is just return statement from. So this here we are getting our return statement from all the child nodes. That's all about the distance from root. Then we have to return our answer array. So this will give us return distance from parent and child. So we have to take both values, and we are passing adjacent. This is the same function, but we have to add one more thing, which is upper distance. So on this current node, we have to add the maximum value that we are getting it from the child nodes, or the upper value that we are getting from parent value. So distance from parent and distance from child, we have to add the maximums. Then we are going on the neighbor nodes, the child nodes. So from child nodes, we have to reach this current node. So node, if this node If this current node is even, we have to add +2, else we have to pass +1. So suppose we are at this level, and from here we are going our neighbor node. So for 4 we have to reach this node. So uh, that's the thing that we have to add on every single thing. So we are going on our neighbor nodes. If this neighbor is parent, just skip this, as we have to find our child. So suppose we are going here. So from 2 we have to track, is the maximum value we are getting it from this node, from this vertex. So the maximum child of this current node, we are getting it from this neighbor node. Then we have to take this second maximum value, as we will take the maximum value. Then we will go onto our neighbor node, passing our current node as a parent. Then to reach this node, we have to add this thing. If this is even or this is odd, then we have to take the maximum. So from here we have to take the maximum from parent. So this is the upper distance that we are getting from parent, upper distance, or the child distance. We have to take this two ways. That's all. And we have to pass our answer, the answer we are storing, and we will return our answer. That's all. Let's submit this code. If you need the Java code, so just comment down below. I will provide you the Java code. And we have successfully solved this question. That's it. Subscribe.